So in the previous video, I mentioned that in data mining and machine learning, we use historical data to make future predictions. And to do that, we need some details. Okay, so that's a very generic statement. We use historical data to make future predictions. Well, we really do that in life anyway. We take the things we've seen previously and we try to make predictions. So if you've done something a bunch of times, you can get a better idea of how it'll work in the future. But when we're working with a computer, we need some structured data. We need to have input. Our historical data actually needs to have some formats and some specifics, so we can feed it to the different types of learning, of the different types of algorithms that we'll be using. And so as I mentioned, the first two that we'll be using are numeric prediction and classification. So what we tend to do is have historical data of some sort, and there's two ways to do that. And one of the easiest ways is to have training data. And then with that, we feed our training data to our software or our algorithm, or however you want to think about that. So in our salaries example, our training data is the salaries. And in our play and not play example, that we would feed to the J48 algorithm, the classifier that would make a decision tree. That would be our play and not play data. So we have our training data. And what a lot of times we'll do is if we have enough data, we will take that training data and then feed it to our algorithm. And then we have our test data. And so typically we have a bunch of data from the past, and we take a little portion of it. So our training data, say we have 100 records, 100 instances. We take 90 of those and make some sort of trainer. We train it, and then we train our classifier, or our numeric prediction, I should say, and then we test it on those last 10 records. And during that testing, what happens is we built our model, our decision tree, our linear regression line. And then when we test it, we say, okay, how accurate was it? So in the case of a classifier, if our model said to play and it turns out we actually didn't want to play, then that's a miss. That's a bad one. And then when we had, if you remember going back to our confusion matrix, remember this guy? We had our positive case and our negative case. And then so in this would be play or not play. And then we had our prediction and our actual. And I should write that down here. And so when it gets it correct, we have our true positive or true negative, and when it gets it wrong, we go in these boxes. And then so that's how we can determine how good our classifier is. And there's a bunch of different what are known as metrics that we can measure it, because there's actually, it turns out, a bunch of different ways we can measure how well our algorithm works, our J48 or our linear regression. And what can happen is that, well, we'll go into that later. There's an issue called overfitting, that you make the model not generic enough, but we'll go into that later. But this is what we'll be working with. We have our training data and our test data, and so this is the simplest way to break it up. And there's another method called cross-validation. Okay. So cross-validation is very similar to having training data and test data. And what cross-validation does is it randomizes all the data. So say we have 100 records, and then it shuffles them up so that the records aren't in order in any way anymore. And typically you'll see either five-fold or tenfold cross-validation. And so say we have 100 records, and then the first step would be to shuffle it, and the algorithm, I shouldn't say so much the algorithm, the software that you're using will do a pre-processing step, and it will shuffle the data. And then let's, for this example, say that we have 1, 2, 3, 4, 5. So say we have five-fold cross-validation. And so this is 100 records. And then so what it's done is broken this up, our 100 records, into groups of 20. And so what you'd do on the first pass is you'd train your software, your model, your J48 or your linear regression on these. And then this last one would be your test. And so it could determine how well the algorithm worked with all its parameters and all the different inputs that it can take, and so you would get some metric. And so what the nice thing about this is, before we had our training data, our test data, and it was set. So we had, say we trained it on 80 records and tested on 20. With cross-validation, what we can do is we can go through these. So in this first pass, we train on this group and test on this group. Well, then on the second pass, we train on this, and then the last one, and then this guy right here will be our test. And then so, as you can see, it makes pretty well sense that we go through and for each one we do that, and then this time we test on this guy, and then on the last pass we test on this guy. And then so as you know, we noticed instead of just getting one pass as we got with our training and test data, in this instance we actually got 5 passes. And so this is a pretty common method that you'll see. That way it gets use of all your data, and you can make a very good model. And you'll see that in Weka. You'll have different options. You can either feed it separate training and test data, or most people will use the cross-validation. And we'll talk about the problem of overfitting and input data a little bit more when we get to working with some examples. But I wanted you to understand that this is the general method of feeding your data to Weka.